There are two types of probability that I want to talk to you about right now. And one of them is independent probability or independent events, and the next one will be dependent. Okay, so we talked about probability in the last video and how it's the likelihood of something to occur out of the total possible outcomes. And we calculated some simple probability, and it was independent probability. So what is independent probability? Independent events are when one event does not affect the probability of the other event. Okay, so in order to find the probability of independent events, you find the probability of the first event, find the probability of the second event, and then multiply the two probabilities. You probably noticed in the last video that that's exactly what we did when we flipped the coin 3 times or rolled the 2 die. We multiplied those two probabilities together. They were independent, so we could do that. So I'm going to run through a couple of these practice problems and answers with you to kind of give you a better idea of independent probability and what independent events look like. So let's go through these quickly. A number cube is numbered 1 through 6. And what's the probability of tossing an even number and an odd number? Okay, so you find the probability of the first event. Let me pick a different color here, which is 1/2, which is tossing an even number. And we discussed last time the even numbers are 2, 4, 6, and 8. So we got 1, 2, 3, 4, 5, and 6 on a number cube, and these 3 are even. So 3 out of 6 is our original probability, and we reduce it to 1/2. Okay, what's the probability of the second event happening? Well, that's also 3 out of 6. Okay, so the other event is the odd numbers, which would be 1, 3, and 5, and that is also 1/2. So 1/2, and then we multiply both of the probabilities. 1/2 times 1/2 is 1/4. All right, let's walk through these. Number 2, a spinner is equally divided into 5 slices. 2 slices are red, 1 is green, and 1 is blue, and 1 is yellow. What's the probability of spinning 1 red and 1 green? So let's look at the different colors we got here. We got 2 red, 1 green, 1 blue, and 1 yellow. What's the probability of spinning 1 red? So let's go back to our red. There are 2 reds, so we have to do 2 out of 5 total for red. Then we go back and say, how about green? Well, there's 1 green. So there's 2 red, 1 green. And that is 1/5, 1 out of 5. So we multiply 2 out of 5 and 1 out of 5 for 2 out of 25. Top to top, numerator to numerator, denominator to denominator, 2 out of 25. That is our final probability. This is independent. The second event happening the first event doesn't impact the second event. The second event doesn't impact the next event, okay? Using the spinner in item 2, we're working on number 3. What's the probability of spinning 2 reds? Well, the probability of spinning a red, we've already determined, is 2 out of 5. And the second time will also be 2 out of 5. If you take a spinner and it's got 5 sections, there's 3, 4, 1, 2, 3, 4, 5, and 2 are red. If you spin the spinner, like let's say we got a spinner and you spin it, it lands on red. The 2 pieces of red will always be there. So there's 2 out of 5 times 2 out of 5, which is 4/25. Number 4, use the spinner in item 2. So there were 2 red, 1 is green. Let's make it green. 1 is blue. If you can see the blue. And 1 was what? Yellow? Ugh. And 1 was yellow. My green and my yellow kind of go together, but you get the idea. So number 4, use the spinner in item 2. What's the probability of spinning a red? Well, that's 2/5. We've already determined that. The red are 2 out of the 5 times, spinning a red, a green is 1 out of 5 times a yellow, which is also 1 out of 5. So we multiply straight across. 2 times 1 times 1 is 2. 5 times 5 times 5 is 125. So we write the answer is 2 125ths. Another way to write 5 times 5 times 5 using exponents would be 5 to the third power if you want to use your Desmos calculator. Okay. Compare the probability, number 5, compare the probability of tossing a coin twice and getting 2 heads and tossing a coin twice and getting a heads and tails. So the first scenario is tossing that coin twice, first toss, second toss. It's both 1 out of 2 for landing on heads. So we multiply those and we get 1/4. Now we're going to compare that to tossing that coin and getting a heads the first time, 1 out of 2, and a tails the second time, 1 out of 2. We multiply them, it's also 1/4. So really the probability is the same. These are all examples of independent events. Okay, independent events. So I hope this video helps explain independent events for you guys. Now let's talk a little bit about dependent events. Dependent means something depends on something else. Events are dependent if the occurrence of one event, let's see if you guys can see this, if one event affects the probability of the second event. For example, you have a deck of 52 cards. The probability of pulling a certain card is 1 out of 52. So if I said pull Ace of Hearts, it would be 1 out of 52. If you do not replace the card back into the deck, there are now 51 cards in the deck because you didn't put it back in. The probability of pulling a specific card on the second draw is now 1 out of 51. It went down by 1. The denominator decreased by 1. The probability of the second event is affected by the first event. The first event removed a card from the deck and changed the probability of the second event. So this is how you determine the probability of dependent events. Find the probability of the first event. Determine how the first event affects the favorable outcomes and total outcomes. Find the probability of the second event. Multiply the two probabilities. So in each scenario, we are multiplying our fractions. So let's work through this example. A bag contains 3 red and 4 blue marbles. So there's 3 red and 4 blue for a total of 7 marbles in the bag. Okay, so let's keep that in mind. We got 3 plus 4, so we have 7 marbles. You draw out 1 marble and do not return it to the bag. You then draw a second marble. What's the probability of drawing out 2 blue marbles? So let's take the probability of the first event. There are 4 blue out of 7. So this is the first event, 4 out of 7. If you remove 1 blue marble, you are left with 3 blue marbles in a bag of 6 total marbles. So now there are 3 out of 6. That's the second probability, the second event. And you multiply these two fractions together, 4/7 times 3/6, and you get 12 over 42, 12 42nds, which reduces to 2/7. Okay, so let's walk through a couple of examples. Let's do some practice. A bag contains 4 red, 2 blue, and 1 green marble for a grand total of 4 plus 2 plus 1 for a grand total of 7 marbles. You draw out 1 marble and do not return it to the bag. That's key. Do not return it to the bag. Then you draw out another marble What's the probability of drawing out a red and a green? So how many red are in the bag? Well, we got 4. So 4 out of 7 are red. If you remove a red marble, you are left with 1 green and a bag of 6, okay? The green, we're not impacted. So you have 1 green in a bag of 6, so that is your fraction. There's 1 green in a bag of 6. There's 4 red in a bag of 7, and you multiply them for a grand total of 4 42nds, which reduces to 2 21st. Let's do numbers 2 and 3 together. You number slips of paper from 1 to 10, a different number on each slip, and place them in a bag. You randomly pick a number out of the bag. Key information: you do not replace the number back into the bag, and you pick a second number. What's the probability of pulling a 2 and a 4? Okay, so the probability of pulling a 2 is 1 out of 10 numbers. You only have one number 2. You don't put that back in the bag. So now you got to multiply that to the probability of getting a 4, which is 1 out of 9. You take your total number of numbers in the bag, you have to reduce it by 1. You multiply straight across, you get 1/90th. Okay? These are dependent events. Use the bag of numbers from item 2. What's the probability of pulling 2 even numbers? So let's list our numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Says you pull 2 even numbers. Well, let's highlight all our even numbers. 2, 4, 6, 8, and 10. 5 out of the total 10 are even. But you don't pull it back into the bag. Okay? It doesn't say that in this scenario, but let's assume it because we're doing dependent probability. So what's the probability on the second time you pull a number out? So now there's only 4 even numbers in the bag out of a total of 9. So you multiply straight across and you get 20/90ths or 2/9. It reduces. They both divide by 10, so it reduces to 2/9. These are examples of dependent probability. So we have 2 types of probability. We have dependent and independent. I hope this helps you guys remember what each one is and how they are impacted. Next thing I want to point out are some key phrases that we think when we're talking about these 2 types of probability to keep in mind. Independent probability. Pick something out of a bag, return it. Pick someone from a group, let them go back in. Denominator stays the same for each pick. Okay? Item has the same probability of being picked each time. The key words you need to remember for independent probability are the item is replaced, it's returned, or it's put back. So you got to look for these key words as you read through the problem. There can be multiple picks as long as one item is picked at a time. Like when we flipped that same coin 3 times, it didn't change the probability of getting heads. It was the same coin each time. We didn't have 3 different coins. It was the same coin, and then we multiplied them. That's independent. Dependent is you pick something and you keep it out. So that means the denominator decreases after each pick. Item has a better probability of being picked each time. So let's say, for instance, I have 10 kids in my class, 10 different kids. And if I pick Joey, there's only one Joey out of the 10, so that's 1 out of 10. But I don't put his name back in the spinner. Now the next time I pick a name out of the spinner, it's going to be 1 out of 9. And then the next time I use the spinner, it's going to be 1 out of 8. The denominator keeps decreasing in this situation because I've taken that person out of the mix of the prize, so to speak. There can be multiple picks as long as one item is picked at a time. The key words to remember here are you keep it, you do not return it, you don't put it back. Okay? So this should help you guys remember what the difference is between independent and dependent probability. All right? This time the denominator stays the same. This time the denominator decreases by 1 each time.